Nuclear. Energy. Nuclear. Energy.
Uranium. Plutonium.
Боевой ракетный комплекс шахтного базирования с ракетой РС-20 по натовской классификации «Сатана».
Производим путь. Даю отсчет. 5, 4, 3, 2, 1. Пуск.
СС-18 в конструкции Михаила Янгеля и Владимира Уткина, которую на Западе прозвали «Сатана». Ракета имела разделяющуюся головную часть с 10 ядерными блоками. Каждый из них наводился на цель с точностью 400 метров. Полетные задания закладывались в память компьютера, поэтому время приведения «Сатаны» в полную боевую готовность составило всего 30 секунд. Для предстартовой калибровки командных приборов боевым расчетам уже не нужно было вручную подключать наземное оборудование.
Fragmentos inéditos de las pruebas del misil balístico intercontinental Bulava, que en un futuro constituirá el núcleo de las fuerzas nucleares navales de Rusia. Este misil tiene alcance de más de 8.000 kilómetros y puede portar cabezas nucleares hipersónicas independientes, capaces de modificar la trayectoria del vuelo, lo que permite burlar los sistemas de defensa antimisiles. Se prevé que el misil portará 10 cabezas nucleares. El Bulava, diseñado en el Instituto de Termotecnia de Moscú, es capaz de vulnerar cualquier escudo antimisil blanco. Los últimos 2 lanzamientos fueron exitosos. Tras pasar todas las pruebas previstas, estos misiles se instalarán en submarinos nucleares de última generación. Rusia construirá 8 submarinos de esta clase y cada uno portará 16 misiles Bulava.
Estados Unidos es la nación con el mayor arsenal nuclear en el mundo. Posee más de 5.000 ojivas estratégicas, más de 1.000 armas tácticas operativas diseñadas para el campo de batalla y 3.000 ojivas tácticas y de reserva. Le sigue Rusia con 5.000 ojivas estratégicas, 3.500 ojivas operativas y más de 11.000 ojivas estratégicas y tácticas almacenadas. Muy por debajo se ubica China con 300 ojivas estratégicas y 120 tácticas. Francia también con 300 ojivas estratégicas, Reino Unido 200 ojivas estratégicas, India entre 75 y 115 ojivas, Pakistán entre 65 y 90 ojivas estratégicas y Corea del Norte, que posee entre 1 y 10 ojivas nucleares. Además, existen amplias sospechas de que Israel posee un arsenal de 200 ojivas nucleares, aunque nunca haya sido confirmado ni desmentido por el propio país.
It would come as a surprise. The secure communication system transmitting to the Ohio-class U.S. submarine fleet would be the first to receive the command. Patrolling both the Atlantic and Pacific Oceans, they are undetected. Fourteen of the 18 warships are equipped with 24 Trident missiles each, Trident 1s and Trident 2s. The remaining 4 are armed with 154 Tomahawk cruise missiles, which can be outfitted with nuclear warheads. The fleet as a whole represents half of the... A single Trident 2 missile is equipped with up to 8 nuclear warheads aboard a multiple independently targetable re-entry vehicle, or MIRV. A single W-88 warhead delivers the equivalent of 475 kilotons of TNT. In the case of a full deployment, the United States could unleash over 400 such missiles with between 6 and 8 warheads each. From the time of launch, it can take less than 10 minutes for an SLBM to reach its target, or as little as 5 minutes if it is flown on a depressed trajectory. This allows a very short margin for reaction. Early warning radar systems in Russia, China, and elsewhere immediately detect the missile plume. They can determine the trajectory and intended target of the missiles. Minutes fracture into seconds. This is not a test. This is not scheduled. Russian nuclear command and control systems, carried over from the Soviet era, leave little time to opt out or delay a full-fledged response. Within 50 seconds, the missile has peaked above the Earth's atmosphere. It reaches its top speed. The engine drops off. The bus releases multiple warheads as well as decoys. The radar systems on the ground are overwhelmed and unable to differentiate the two when they are in post-boost phase. Re-entering the atmosphere, the decoys burn off, and the warheads enter their terminal phase. It will be less than 180 seconds before they touch down.
That goes off in full in the first shot. Now you have in the submarines, you have the warheads you have not yet discharged. Those go along the way as a second wave. After that, you're pretty much out of weapons. After which, most everybody is dead. Most logistical systems are dead, non-functional. You have a situation where the effect of this kind of firing creates a continuing effect which may go for several years. Now, instead of having one bomb, which is really it's a nuclear super bomb, with thermonuclear implications. Now imagine you have the same kind of thing, or less, and you have not one big bomb. You have a whole barrage of such things. The exchange involves Russia. It involves China, which has a very significant thermonuclear arsenal. It implicitly involves India. It involves the United States. It involves the extermination virtually of Western Europe.
The current world population is 7 billion persons. The current global nuclear arsenal is approximately 5,000 megatons. After a full nuclear exchange and the immediate loss of life at the points of direct impact and surrounding fallout zones, the ongoing environmental, climatic, and social consequences continue for years. The dust and soot picked up from fires, burning cities, and other target sites has been compared to a volcanic eruption, but far more long-lasting. A regional nuclear conflict, employing only 0.3% of the global nuclear arsenal, would potentially result in 1 to 5 million metric tons of black carbon that would be spewed into the Earth's atmosphere. A spring or summer attack, or an attack in the extended region of the subtropics, would inevitably cause the smoke injections to heat, absorbing shortwave radiation, and to rise. Within a week, what is not washed out immediately in black rain has risen through the troposphere and into the upper stratosphere, where it will remain for many years. The smoke cloud and the absorption of residual particles plunges global surface temperatures. While a regional nuclear exchange could result in global surface temperatures decreasing by 2 degrees Celsius, a large-scale nuclear conflict could alter these temperatures by -7 degrees or more. In the depth of the last ice age, some 18,000 years ago, the temperature difference from today was -5 degrees. Famine for billions of people far from the target zones would be the result of a -2 degree change. Growing seasons would be shortened by nearly 3 weeks, wiping out crops. A change in 5 degrees would sufficiently ruin Canadian agriculture entirely. If world grain reserves were not destroyed in the initial exchange, reserves would last for 71 days, with little, if any, means of transportation. The global hydrological cycle would be disrupted due to the rapid climate change, and global precipitation would likely drop by 45%. The total integrated dose of radiation to living things could reach up to half the level of lethality for human beings, even in regions of the world outside the war latitudes. If nuclear installations were targeted, including plants, fuel cycle installations, and waste dumps, and nuclear materials were vaporized, it would create a very long-lasting impact on survivors. These are only the projected consequences, but it has been said that the effects of a nuclear war that cannot be calculated are just as important as those for which estimates exist. Both, however, are subject to very large uncertainties. These estimated consequences have, so far, survived the scrutiny of scientists in the East and West for the past 30 years.
Nuclear energy. 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 Nuclear